This is 2021 AS Paper 2. It's pure and stats. Express this as a single power of a. So this is a squared, and then this is a to the power of a half. When you divide in and you've got the same base, you just take away the powers. So this is 2 minus a half, which is just a to the 3 over 2, 1.5. So it's this one. On the diagram below, show this. Which one is this? Okay, so you've got the sine graph. It's not being changed in the y direction. It's only being changed by the x because the transformation is within the brackets. So first of all, it can't be, actually it could be any of these. First of all, this one here, this looks like cosine, but then you'll realize that sine of x plus 90 is just cosine. It's the exact same thing. It's just cosine of x. It can't be this one because if you imagine sine starts like this and then goes up. Okay, so its first peak, if you imagine this first peak, it's at 90 degrees and it's being moved to the left here. And then this here will be moved to the left. So then it'll finish like up here. So it's this one here. It's given that dy by dx is this, and you want to find an expression for y. Just integrate both sides so that dy by dx cancels. This is x to the power of a half. Increase the power by 1, then divide by the new power. This is 3. This is a half plus 1, so it's x to the 3 over 2 divided by 3 over 2, which is just this, and then plus c, obviously, because it's just the constant that you need. And then you can just write this like this if you really want to. It makes no difference. Find the binomial expansion of this in ascending powers. There's this formula here. You can use it because it begins as a 1 here at the beginning. And then just wherever you see an x, by the way, this is given in the formula booklet, wherever you see an x, just replace it with a minus 2x. And then just calculate the first 5. What was it? Oh no, just up to x squared. So just go up to x squared using this formula here. So just this, replace the x's with minus 2x's, so you'll get this. And yeah, that's just the answer. Find the first 2 non-zero terms in the expansion of this. This here, we've already calculated it. It's this. We'll just leave it up to x squared. It doesn't really matter. And then the next one here, we've got this one here. You can just use the formula for it, but you don't actually need to, because if you look at this, this is just squared. So it's not too hard to do in your head. It's just 1 plus 10x plus 25x squared. Okay, and then you want to add these together. So you'll have minus 10x cancel with 10x, and you have a 1 add 1, so that's 2x. That's 2 plus 40x squared or 25x squared, which is 65x squared. Hence, use an appropriate value of x to obtain an approximation for this and that. We've got this for the first binomial that we got, and then this for the second one. Okay. Now, if you imagine inside of it, you're looking for what value of x you can actually have. I think this one here, what was it? It was 1 minus 2x. So if we say that 1 minus 2x equals 0.998, x would have to equal 0.001. Okay, so you plug in x equals 0.001 into here. This is just a fine approximation, doesn't really matter. And then similarly here, if you look at 1 plus 5x, if you plug in 1.005 into it, if you make that equal to 1.005, sorry, and then rearrange for x, you'll get x is also 0.001. So plug that into there, and then just put those into your calculator and sum them together. Oh yeah, sorry, that was me showing that, where these came from. Okay, and then just put these into your calculator and sum them together. You'll get approximately 2. You've got this, using the cosine rule, find the length AC. Okay, so first of all, if you have a look at AC here, if you call this full length AC x, you can use cosine rule with this length here equals that one there with this angle. So if we call that x, just plug into the cosine rule. You should know this, to be honest. And then you'll get this, okay? And if you just tidy this up to get that, and then you just factorize this factorizes into x minus 5 and then x minus 3. So x can equal 5 or x can equal 3. First of all here, if you imagine this, x cannot equal 3 for this full length. One of the reasons is because there's this thing called the triangle inequality law or theorem. If you don't know this, another way that you can think about it is, well, x could either represent this length AD, because this and this and this are the exact same. Because the only difference, if you look at this one here, this triangle, if you set up cosine rule for this one, it'd be the exact same as if you set it up for this one. Okay, and if you realize, oh well, you know, it makes sense that the longest side, because we're looking for the largest triangle, it must be 5 and not 3. Okay, because you could say that AD equals 3, and then this full length AC must equal 5. So that full length there is 5. Hence the length of AD. Well, the length AD, we've got x equals 5, x equals 3. We just said that AD must equal 3. Do this, and then you want to put it into this form. Okay, so if you do log base 5 of both sides, log base 5 of 5 will cancel, so you just have 2x plus 4, and then you have log base 5 of 9. Okay, and then just subtract 4 and then divide by 2 to get this. Just look carefully at how they want this log. They don't want any scale factor in front of it. This is just the same as saying 9 to the power of a half, and then 9 to the power of a half is just 3. Okay, so and then just, you know, swap these two numbers around so it looks like this. State the coordinates of A, B, and C. We've got this. Okay, so when x equals 0, so here, A is just a y-intercept. So if you plug in x equals 0 into there, y equals 2. Okay, so A is 0, 2. Okay, and then what are B and C? Well, it's when y equals 0. If you set that as y equals 0, and then factorize that, you'll get x equals 2, x equals 1 as your solutions. Just by inspection, you can see that B must have x coordinate 1, and then C must have x coordinate 2. And then obviously the y coordinate is just 0, because that's what we've set up here. Katie is asked by her teachers to find the total area of the two shaded regions. She gets the answer as 2/3, and apparently it's wrong. The reason why it's wrong, okay, well, if this curve here is this function, okay, what she's done is she's integrated from here to here. The reason why this is wrong is because this area under here, it would yield a negative result because it's below the x-axis, and so it's kind of cancelled down with some of this positive area here. Okay, hopefully that makes sense. You should know this, by the way. So you should know this, like, if you wanted to get the correct answer for this, you'd do the integral from here to here, so from 0 to 1, and then you'd add it to the absolute value, or the positive version, or the integral from here to here. Now, if you know that, so that's what we'll do. So we've got the integral from 0 to 1, okay, and then instead of just doing the absolute value, what you could do is subtract the integral from 1 to 2 here, because you'll have a minus and then a minus, which will just give you a positive. If you integrate this, this is a third x cubed minus 3 over 2x squared plus 2x, and then you would also have a plus c, but it doesn't really matter because it'll cancel out because it's a definite integral. Same thing on this side here, but with just different limits. I think you can actually put this into your calculator and you get the right answer. I've kind of been a bit lazy and just said that this is equal to 5/6 because I put this into my calculator, and then this here would equal minus 1/6. If you don't know how to do this, what you do is you substitute in x equals 1 here, okay, and then you subtract it from this entire thing, but when x equals 0 instead, okay, and then this you do the exact same thing. So plug in x equals 2 and you subtract it from this entire thing, but where x equals 1 now. You'll get this. If you just add those, you'll get 1 square unit. Explain why Katie's method was not valid. I've already explained that. She didn't account for the fact that the curve under the x-axis is negative. It's given that y equals this. Use differentiation from first principles to find dy by dx. You'll get given this definition. You get this in the formula booklet. If we say that y equals f of x, okay, we can say that f of x equals this here, because obviously it's just the same. Okay, and then f of x plus h is just where instead of plugging in x, you plug in x plus h. Okay, and then we're just going to use this and just plug it into there to get that. Just tidy this up and be very careful here. You've got a minus, so it'll be a minus 3x and then a plus 5x. And I've also expanded that. You can just tidy this up a little bit more. I'm sure you know how to do that. And then here you can cancel out h's because you've got h's in all of them. Okay, so now it's the limit from h equal from as h approaches 0 of all this. This here will go to 0 because, you know, h 0 squared is just 0, and then 0 times 5 minus 5 is just 0. So you're left with 3 minus 10x, which is just the answer. Express n cubed minus n as a product of 3 factors. Just take out an n, you get this. This is a difference of 2 squares, which is that. Given that n is a positive integer, prove that n cubed minus n is a multiple of 6. The way that they did this in the mark scheme is a little bit different, and I'll explain how they did it first, and then I'll show how I did it. But the way that they did it is they said that n minus 1, well, these here, this, and that, are just consecutive integers. N minus 1 is the first one, and then n is the next one, and then n plus 1 is the next one after that. And every group of 3 integers, one of them will always be it will always be a multiple of 3. So if you have a multiple of 3 multiplied by like any of these numbers here, it will be a multiple of 3. Okay. Similarly, in every group of 3 numbers, one of them will always be a multiple of 2. Right? Okay. And it's just exactly 1. So that means if you're multiplying that by this number here, 2 multiplied by any of this is still a multiple of 2. And now you're multiplying by a multiple of 2 and by a multiple of 3. So it's a multiple of 6. Okay? Because if you're a multiple of 6, you're a multiple of 3 and a multiple of 2. So that's the way that they did it in the mark scheme. I didn't do it that way because I didn't think of that. I said let n equal 2m plus 1 if it's odd. Okay? And obviously multiple of 2 and multiple of 3 for this. And then I've just plugged it into here to get this. And then I've expanded that and expanded it more to get this. And I've taken out a 2 to show that this actually is a multiple of 2. Okay? And then I did a proof by induction here. I don't think this is in your spec for year 1, but this is just the way that I did it. You can do it the consecutive integers way, which I explained. I don't think you did like get drop marks for doing it this way because it's an accurate method that you can use. But I've said that n cubed minus n is a multiple of 3m, where m is just some random number. Okay, and then what I've done is I've just plugged in for here, I've plugged in n plus 1 and then n plus 1 into here, right? Because we've already, like, this is the case where n equals just n, okay? And then I'll check the number after it, which is when n equals n plus 1, okay? So I've checked n, it's this one here, and I want to see if the next, and then I want to see what n plus 1 is, so just the next one. This might not make much sense if you've not done proof by induction, so maybe just stick to the consecutive integers way that I explained last time. So checking n plus 1, you get this. Expand this very carefully and then simplify it to get this. Now, we said that n cubed, we can say that n cubed is 3m plus n, because that's what we've set up here. And if I plug this into there, I'll get this, and then tidy up a bit to get this. Factor out a 3 from there, so it is a multiple of 3. It's a multiple of 3 and a multiple of 2, so it's a multiple of 6. You've got this here, and you want to show that the capacity is this. Okay, so if this is 30, you've got a length of x here and a length of x here. Actually, first of all, let me just explain what's going on here. If this is a length of x, this is also a length of x, and what they've done is they've taken off these corners and they've folded it up. So if you imagine you fold this entire rectangle up this way, this length here, which is x, will be the height, so this is x. Okay, you've got x here and x here, and this full thing is 30, so this here is 30 minus 2x. Okay, and now you've got 30 minus 2x here, and you've got 30 minus 2x here. Okay, so if you just multiply those two together, okay, I've written this twice for some reason, you'll get this. Oh no, I've actually missed out a step here. I meant to say multiply by x here as well, so it's this multiplied by that multiplied by another x, but you should get this here, because you're looking for the capacity. So it's 30 minus 2x multiplied by 30 minus 2x multiplied by x. Apologies for that. Find the maximum capacity of the box. X is less than 15, it tells us up here. Okay, you need to use that for later. So this is 30 minus 2x, and we know that the capacity is this. If you differentiate this, you'll get this. Okay, if it's a maximum, if you imagine the curve, it's like a parabola. Let me just check this for a second. Yeah, so if it's like a parabola, then you want where it's like you want the value of x which maximizes it. Okay, so you want the highest number, and if it's a maximum, it's going to be at the top. So you know it's a stationary point, and stationary points occur when dy by dx equals 0, or in this case dc by dx. So that equals 0. Divide by 12 on both sides, you get this. You can factorize that into this. X cannot equal 15 because it's less than 15, so x equals 5. We want to show that this actually is a maximum. So if you plug in, if you check the second derivative, so just differentiate this again, you'll get that. Plug in x equals 5, and you'll get minus 240 plus 120, which is minus 120. Therefore, it is a maximum. Okay, and this is the value of x, which maximizes this function here. A circle C has center this and radius that. You should know the formula for a circle. So it's x minus a all squared plus y minus b all squared equals radius squared. Radius squared here, if the radius is root 20, radius squared is 20. And then this will be x squared plus y minus 10 squared equals 20. So you've got that. We're told that y equals mx, so just plug in mx into there. Expand this, and then tidy up, and you'll get this here. Okay, I'm just going to factor out an x squared from this, because then you can see this is the coefficient of x squared, and then minus 20m is the coefficient of x, and that'll be helpful later. But anyways, that's exactly how it wants it now. So we've got this, and we want to show that they've got equal roots. So if they've got equal roots, the discriminant is equal to 0. B here is minus 20m, and then A is 1 plus m squared, and C is just 80. So plug that in, expand that, and then just rearrange a little bit to get this. Divide by 80, so m squared equals 4, so m equals plus or minus 2. Okay, m can either equal plus or minus 2, because if you think about it, here, it's not like a length, it's not anything that, you know, restricts it to being positive, so it's positive or minus 2. Another way that you could do that is by bringing the 4 to this side, so you have m squared minus 4, and then factorize that into m plus 2 and then m minus 2. Two lines are drawn from the origin, which are tangents to C, the curve C. Find the coordinates of the points of contact between the tangents and C. So we said that m equals 2 or m equals minus 2, okay, and we have this, we have that equation for the circle there. Okay, now let's check first of all where m equals 2. Okay, so if we plug in m equals 2 into here, you have 4 plus 1, which is 5, and then this is going to be minus 40. Okay, x plus m 80 equals 0. Divide by 5, you get this. This is a perfect square, x minus 4 all squared. So x equals 4. Okay, y equals mx, because that was the curve, that was the line which went through the circle. So when x equals when m equals 2, and then when x equals 4, so 4 multiplied by 2 is 8, so y equals 8. Okay, so the coordinate here is 4, 8. And now it's the same thing here, but plug in m equals minus 2. Okay, you might be able to just tell that it makes this into a positive. You could just do it the longer way, but anyways, you'll get this. Divide by 5 on both sides. Now you get x plus 4 all squared equals 0, so x equals minus 4. You've got y equals mx, but now you've got m equals minus 2, and then x equals minus 4. So minus 2 multiplied by minus 4 is positive 8. So the coordinates are 4, 8, and minus 4, 8. This is the stats part of the paper now. We've got this massive table, and deduce the sampling method most likely to have been used to collect this sample. Okay, first of all, let's read what they've actually done. So it's the total monthly rainfall in millimeters over 6 years, and it was taken from a dataset covering every year from 1768 to 2018. They've not filtered the data in any way. They've just used a single specific method to calculate, to get all of this. It's systematic. Okay, it would be stratified if they say if they only checked months where the rainfall was over, say, like 60 or something like that. But in this case here, it's just systematic. It's obviously not simple random or opportunity. I'm hoping you can tell that. Find the probability where y is greater than 0 but less than or equal to 3. So we want to be here, here, or here. If you go up the y-axis, you'll find this, that, and this. Sorry for that. And you just want to sum these together. If you sum them together, you'll get 0.58. The mean of t is denoted by mu. Random variable t is distributed as this. Okay. The mean, you should know, is just m multiplied by p, so 16 multiplied by 0.3. Okay, and we want where t is less than or equal to 4.8. Now, you can't actually plug in decimal values, because the way that you actually solve this is by using the choose function, if you know the formula. And you can't have factorials of a decimal number. So you just truncate it. So you just get rid of the decimal. So it's, you take this. Okay. If you plug that into your calculator, you'll get that as your answer. Find the variance of t. The variance is npq. Okay. I think you are given that, where q is just 1 minus p. 1 minus p is 0.7. So it's 16 times 0.3 multiplied by 0.7, which is 3.36. Write down the letter that identifies this point. There's an error, so there's like an anomalous result. It's clearly F. I mean, I'm sure you can tell that. Suggest one possible action that can be taken to deal with this error. Just exclude it from any calculations or from the data itself. The scatter diagram proves that longer hours of sunshine causes higher maximum daily temperatures. Well, no, because just because there's a correlation doesn't mean it causes it. So correlation doesn't mean causation. Find the reduction in mean CO2 emissions in 2016 compared to the mean of the CO2 emissions in 2002. So the mean here is this full amount of a 1215. Okay, so that's the mean for 2002, and then the mean for 2016 is just this over that, and you want to subtract. You just want to subtract them together. If you did this one, subtract that one, you'll get a negative result, but just take the positive. Just take the absolute value of it if you want to. Anyways, yeah, if you do that, you'll get 47. Using knowledge of the large data set, state whether you agree with this claim. She claims that the move to more electric or gas petrol-powered cars has caused a reduction in the mean CO2 emissions found in Part A. If you know your large data set well, if you've revised it, you'd realise that there are actually many electric cars within it. So the number of electric cars wouldn't have been significant enough in 2016 to be able to cause such a significant change. So it says there are 3,827 data values in the large data set, and she's saying that it must be summarized incorrectly, because if you sum this at this, it equals 2359 and not 3827. So that's why she's saying this. Okay, is she correct for saying it? No, because there are other categories in the large data set that could account for the other data values, so the difference, such as there's a company car category. If you look into the car section, and the number of toilets. So basically, you've got all this. They sum to 200. Okay. A is the probability that it has exactly 2, and then B is the probability that it's detached. So B is this, this, or that, and then A is this, 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 or this. Probability of A is this, 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 and that added together, which is 100. But it's over 200, so it's 100 over 200, which is a half. And then you want to find the probability that is A and B, except it's not in A. Okay. So A is this. Okay, and then B is going to be 12. If you think about B, it's going to be 12 plus 10 plus 8, except it's not in A, so it's not this one, so it's just 12 plus 8, which is 20, and then it's 20 over 200, because the total here is 200, which is the same as 1 over 10. Probability that is A or B, so it can be this, 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 or this and this. We're not going to add this one again, because we've already accounted for it. So you sum all those together, which I've just said, you'll get 120 over 200, which is the same as 3/5. Determine whether A and B are independent results, independent probabilities. If they're independent, the probability of A and B should equal the probability of A multiplied by the probability of B. I think you get given this in the formula booklet. The probability that it's A and B, so it's this in this column here, and this row is just 10. Okay, so it's 10 over 200, which is just 1 over 20. And then the probability that it's A, we've already calculated this last time, so it's 50 add 30, which is 80. 80 add 20 is 100 over 200, so that's a half. Okay, and then probability of B is going to be 20, and then add 10, so that's 30. So 30 over 200. Okay, if you add that to a half, you'll get 3 over 40, and these are not equal, so they're not independent. Using this table, write down 2 events other than this which are mutually exclusive. So you could either have just 3 toilets, or you could just have 1 toilet. So those are 2 mutually exclusive events. You could also say that it's just this, or that it's just this, or that it's just this. It's known from previous data that 14% of the visitors to a particular cookery website are under the age of 30. You want to encourage more people to target, so they've started a campaign. They're taking a a sample of 60 people and only 15 of them were under 30. Explain why one-tailed hypothesis test would be more appropriate. It's because we're only checking, we only need to check that it's increased. You could check it that it's decreased if you really wanted to, but the important thing is you only need to check one of them. Because if you've checked that it's decreased, you can determine that it's not effective. And then if it's increased, then you can say that it is effective. Okay, so technically I should have only written increased because it wants to see that it was effective. But you could also infer that if it's decreased, it was not effective. So, you know, either one are the same thing. And we only need to check one of them to determine the effectiveness. Carry out the hypothesis test at this 5% significant level to show that the number of people under the age of 30 has increased. If we say that X is the probability that they are under 30 years old, we can say that X is distributed as 60, which is the sample size, multiplied by the probability with which they are under 30, which we said was 14% last time. So that's 0.14. And we're saying that the null hypothesis is that it actually is 0.4, and then the alternative hypothesis is that it's increased, so it's greater than 0.4. So if we assume the null hypothesis to be true, okay, we saw that there was how many? 15 people which were under the age of 30. So under H0, where P equals 0.4, we want to see that it's larger than or equal to 15. It's always an equal to sign here, but it's just that it's larger or equal to 15. Your calculator probably doesn't take it in like this. So what you can say that it's 1 minus the probability of X, which is less than or equal to 14. Careful, it's 14 here and not 15, because otherwise you'd be counting 15 twice. So it is this. Okay. I don't have a calculator, so I wrote it like this. You don't need to know what any of this means. It's the same thing as doing this here. I only did it this way and put this into Wolfram Alpha because I don't have a calculator. Anyways, you'll get your answer from this as here, if you put this into your calculator. You know, you might understand what this is. You kind of should, because this is in your formula booklet minus the summation. Actually, I'm not sure if you do summations in year 1, but anyways, it'd just be this. Oh no, you would, because you do standard deviation, yeah. So, you know, you might understand what this is if you just look at the formula booklet and look at, you know, the binomials sections. Anyways, yeah, you'll get this as your answer, and then you compare that to the 5% significance level, which is 0.05, and you see that that's less. Okay, so that means you reject H0, so you reject the null hypothesis because there's sufficient evidence for the alternative hypothesis because it's much greater than this. And that's the entire paper. Thank you for watching.